Heliophysics is the study of the Sun and its interactions with the Earth and the solar system. The Earth's atmosphere has four primary layers. The lowest is the troposphere, then the stratosphere, mesosphere, and thermosphere. These layers, particularly the upper three and the existence of ozone in the stratosphere, protect our planet by absorbing harmful ultraviolet radiation. NASA scientists use balloons to collect in situ measurements of the atmosphere. Sounding rockets are used to collect more detailed data in the mesosphere and the thermosphere, both of which are too high for balloons. Satellites are also used to gather measurements of the upper atmosphere. NASA's Aeronomy of Ice in the Mesosphere AIM satellite remotely senses unique night-shining clouds made of ice crystals at an altitude too high for water vapor clouds. These noctilucent clouds form over the summer poles and vary in brightness throughout the year. Satellite data reveal a trend of increasing brightness of noctilucent clouds over the past few decades. Since the mesosphere is responsive to small changes in atmospheric chemistry and temperature, noctilucent clouds may provide clues to the interaction between natural and human-caused changes in the atmosphere. In 2011, observations show dramatically lower ice content above the southern pole, caused by a pulse of warm air in the upper atmosphere. NASA scientists theorize that these warm temperatures were triggered by changing weather conditions in the northern or opposite hemisphere. Researchers hope noctilucent cloud data will contribute to the understanding of how the Sun's cycle affects the Earth's atmosphere and pole-to-pole atmospheric circulation. Higher altitude does not necessarily mean colder temperatures, because temperature does not change consistently through the layers of the atmosphere. Temperature decreases with altitude through the troposphere, but then increases through the stratosphere. Conversely, the temperature decreases in the mesosphere, and it contains some of the coldest temperatures in the atmosphere. The thermosphere then begins to warm with higher altitude. The thermosphere warms because molecules of oxygen and nitrogen move faster at this altitude and are bombarded by radiation and energetic particles from the Sun, causing the molecules to split into their component atoms. Both the speed of the molecules and splitting of the atoms create heat. The atomic oxygen and nitrogen cannot radiate the heat from this absorption, causing the thermosphere to reach temperatures as high as 2,000 degrees Celsius. As the Earth rotates, the thermosphere is exposed to highly energetic ultraviolet and X-ray solar radiation that ionize the atomic oxygen and nitrogen in the thermosphere. These charged atoms form a layer of plasma called the ionosphere. The ionization of atoms can extend down as far as the mesosphere. However, these upper atmospheric layers are still mostly neutral, with only 1 in a million particles becoming charged daily. The density of this ionosphere layer cycles daily. At night, the ionosphere diminishes as the Sun's radiation ceases to interact with the atoms in the thermosphere. However, there are still small amounts of charged atoms caused by cosmic radiation at night. A unique property of this ionized atmospheric layer is that it reflects shortwave radio waves, enabling communication over great distances by bouncing signals off the ionosphere. However, variability of the ionosphere can disrupt communication. Solar storms is one such variable that can enhance this layer, even shutting down communication between ground stations and satellites. Solar storms can also send highly energetic particles, mostly electrons, along Earth's magnetic field lines into the upper atmosphere at the poles. Here, they interact with oxygen and nitrogen, causing formation of auroras. Auroras are formed when an energetic electron strikes an atom and one of the atom's electrons jumps to a higher energy level. When the electron returns to a lower energy level, energy is released, often in the visible light region of the electromagnetic spectrum. A deep red aurora is caused by the excitation of nitrogen atoms. Excited oxygen atoms create a green aurora at lower altitudes and a red aurora at high altitudes. A small amount of solar particles constantly precipitate from the magnetosphere, forming a background aurora that can be seen from space. NASA's AIM and Themis missions have provided valuable information about Earth's upper atmosphere. NASA's RBSP and MMS missions study the interactions at the upper atmosphere and the magnetosphere from space weather effects.